So we have question 17. The photograph shows an electric motor made by placing a strong circular metallic magnets with like poles facing each other, as you can see here, and at either end of a dry cell. So this is a dry cell. Maybe you have seen on internet this video about the motion of a cell when the two magnetic poles are placed. When a motor is placed on an aluminum sheet, you can see this is placed on aluminum sheet. The motor begins to roll, and magnets produce a magnetic field directly below the cell. These are the magnetic field lines. Explain why the motor start to roll when it is placed on aluminum sheet. First, what is aluminum? Aluminum is a conductor. So means, and these are also metal. As you can see, these are metallic, like metals are there. So when we draw the direction of a conventional current, this will be the direction of the conventional current. That's how the current will move. And this is on the aluminum sheet. So aluminum is also a conductor. So this is the direction of the current. So as a result, when there is a current, what is the effect of when current is in the magnetic field? These are the like poles, how their magnetic field will be there. Look, this is a south pole, this one is a north pole. Okay. And this one is a south pole. And here is a north pole. So the magnetic field lines, because like poles repel, so this will be these are the magnetic field lines. And the direction, because it's a south pole, so direction will be in. Here also direction will be in. So when we connect a piece of, we place it on a aluminum sheet, and there was a cell, the dry cell was placed here. So this is a positive terminal, negative terminal, so conventional current will move. So as the conventional current start to move, the current is perpendicular to a magnetic field. As the current is perpendicular to a magnetic field, it cuts the magnetic field and it experiences a force. So how we write this answer? So there's a current in aluminum sheet because we have a complete circuit. The dry cell, the metallic magnets are there, and below is the aluminum, which is a conductor. So there's a complete circuit. So when there's a complete circuit, the current will flow through the aluminum sheet. And the current is perpendicular to the magnetic field. So as a current is perpendicular to a magnetic field, it will experience a force. And there will be equal. So two things are there. No, any cell you can use. Dry cell is actually, the paste is there inside. The chemicals which are there inside is like a paste. That's why we call it as a dry cell. We can use any cell here can be used. But the idea is that when the current is passing through a wire, it experiences a force. So as a result, there will be a force. Two forces are there. So one is the force on when we work out the direction of the force. So one is the motor, like this effect, it's applying force on the aluminum. As a result, the aluminum will apply equal but opposite force. And that is causing a rotation of this cell. The rotation of a dry cell. So the current which is flowing through aluminum, it cuts the magnetic field and experience a force. So there is a force on aluminum due to a current. So when there is a force on aluminum due to a current, so there will be a force on the motor, like this whole section. One is a force due to the current, and the forces always act in pair. So there will be equal opposite force on the motor, and that force is causing a motor to accelerate, because this force for a motor will be unbalanced force. Is it clear? So it's the same concept. If you look from the sideways, let's say this is a sideway motor is there, and it is placed on the aluminum. So when there is a force on the sheet of aluminium because of the magnetic field, there will be a force according to Newton third law. Forces act in pair. So because of the current, there is a force on aluminium sheet, and as a result, equal and opposite force will be applied on this motor, like what we are calling as a motor. This hole is called as a motor, this hole. So equal and opposite force will be there on this. So equal and opposite force will be there, and that is causing a motion of this motor. Is it clear, this one? So when there's a current, like when there's a current flowing here through a magnetic field, because there's a magnetic field lines, so it cuts the magnetic field line. So as a result, there will be a force on aluminium sheet. So as there is a force on aluminium sheet, according to Newton, pair forces always act in pair. So there will be equal but opposite force on this motor, the whole system, and that is causing an acceleration. As the resultant force act on the object will accelerate. That's why it will move. Is it clear, this concept? Anyone having a doubt or a question? The next is to determine the magnitude of the force acting on the motor. Aluminium sheet is placed at an angle theta. The motor is positioned to roll in a direction AB. An angle is varied until the motor does not roll up or down. The motor remains stationary when B is raised 2.1 centimeter and the length of a sheet is 79 centimeter. So both measurements are made using a ruler which is marked 1 millimeter. Compare this method of finding the angle of about 1.5 to measure the angle with a protractor. So this is related to the least count. Like example, if we measure this angle with the protractor, what about the uncertainty of the protractor? Uncertainty, percentage uncertainty is uncertainty divided by a value recording to 100. So usually a protractor, a 0.5 degree divided by 1.5 into 100. So if I use a protractor to measure this angle, we'll have an inaccuracy, like uncertainty of about 33% if we use a protractor. But if we are using the ruler to measure this angle, because how we measure this angle, we have the height 2.1 and we have this length 79 centimeter. So we have the hypotenuse and we have the perpendicular. So we use a formula sine theta is perpendicular divided by hypotenuse. So there will be a percentage uncertainty in perpendicular and there will be a percentage uncertainty in the hypotenuse measurement, and the total percentage uncertainty always add. So when we are using a scale, when we measure the perpendicular, what will the uncertainty? It will be 0.1 because its smallest value it can record, divided by 2.1 into 100 plus. So this will be the uncertainty in measuring the height, the perpendicular. And what about the uncertainty in measuring the hypotenuse? So it will be 0.1 divided by 79 into 100. So what is the total percentage uncertainty if you use a ruler instead of a protractor? So this will be total about 4.9%. So when we are using a ruler, the scale, and using a ratio, find the angle, the percentage uncertainty is about 4.9%. But when we are using the protractor directly, we have the percentage uncertainty of 33%. So this shows that the method of using a scale and then finding the angle is more accurate as compared to the method in which we are using a protractor. Is it clear? this concept? The next is show that the force exerted on the motor is about 0.02 Newton and the mass of a motor is 69.4 grams. So when the motor, because as you can see, the motor is stationary. If the motor is stationary, the forces which are acting on the motor, the weight of the motor is acting downward. And this angle is, they already mentioned it's about 1.5. So this is 1.5 degrees. Now we resolve the weight into the component. We resolve the weight into the component. So weight will have the two components. And this angle will also be 1.5. So this will be W cosine 1.5. And this will be W sine 1.5. So W sine 1.5, which is directing in this way. And the force on the force because of the changing magnetic field is in this way. If the two forces balances each other, this will not accelerate, like it will remain stationary. So we can say the force which it experience will be equals to W sine 1.5. So that is what we need. W is mg sine 1.5. So m is a mass that is given in gram. So m is a mass which was given in gram. So we divide by 1000, so 0.0694. And gravity is 9.8 and then sine 1.5. So what about the force? The force will be equals to 0.0178 Newton. Is it clear how we worked out the force? Because it was not moving, it was stationary, so the resultant force is zero. So the force which is pushing it to an opposite side, like from A to B, balances with the component of the weight. That's why it is stationary. The next is determine the magnitude of the magnetic flux density through the aluminum sheet. Assume that, so here, if we need the magnetic flux density, we need the force F is equals to BIL. And it is 90 degree, magnetic field and wire is 90 degrees, so F is equals to BIL. Distance between the magnets is given 7.4, so length is given to us. Current is there, force is there, so we can find B. So F over IL will be equals to B. How much force was there? That is from the last part, which was 0.0178. I is the current 3.4 and the spacing between the length 0.074. So that will give us the strength of a magnetic field. So 0.07, and we can say Tesla, or we can also say Weber per meter square. So these are some questions, like most of the questions I did, only like one question left, and that is also related to the one which we have already discussed in the explanation. So this is all about electromagnetic effects.